Hi guys, so welcome to my YouTube channel, and this is in the data analysis playlist, and it's introduction to NumPy, which is short for Numerical Python. So today we're going to be introducing NumPy from the very beginning and talk about a few things that NumPy is used for in the data analysis space. Now, one huge thing here is data analysis. Data analysis is a huge aspect, is a fundamental aspect and a fundamental process of data science, right? And if we talk about data analysis, we should talk about efficient storage and retrieval of data. That this is such an important aspect. We should also talk about efficient manipulation of data. Efficient manipulation of data. And if we think of data in many ways, right? We have so many examples of data. Data can be in many forms. Data can be in so many forms, and here are examples. Data can be an image. Data can be sound. It could be a sound clip. Data could be documents, right? And it could be nearly anything else, right? And data is almost always in heterogeneous formats. So which is you find data all in together, different types of different data types all together. But data can also be represented as arrays of numbers. And so this is where numerical Python comes in, right? If data is represented in numerical fashion, right, then a lot of things can be done. That means you can take data that are documents and convert them to arrays, and it can be manipulated, right? And again, just to let you know, a fundamental part of numerical arrays are a fundamental and absolute part of the process of doing data science, right? So that's where NumPy comes in, converting data into numerical NumPy arrays, right? Provides much more efficient ways to manipulate and perform data operations. So, numerical arrays, right? So with this, you can do data operations, and you can efficient storage, there's speed and all, but at this point data is going to be homogeneous because it comes at a cost, right? Data is homogeneous, so it is typically one, it's just one data type at a time. So it's that. So that's typically what it is. Now, if you're going to be a data scientist, you should understand how to use NumPy. So here, to get to use NumPy, you import the NumPy package. And so here you write an import statement, import NumPy as NP. So that's almost always the convention for which you'd use that, right? And with this, you can always know your NumPy version. So I can say NumPy or NP dot _version, and you can know that. If you look at that, you can see your NumPy version. It could be different for different folks, right? But you can also check the regular documentation for it. Just so you know, NumPy has a documentation. So over here, you can see there's a NumPy documentation, right? If you look over here, you see that there's a NumPy documentation. Typically, I like to encourage folks who are getting started to just check out NumPy for absolute beginners. Then you can see how you can start off simple stuff. NumPy, Numerical Python, is an open source Python library that is widely used in science and engineering, right? So it contains multi-dimensional array data structures such as homogeneous and dimensional ND arrays. So we're going to talk about this, but I just want you to check this out. You can also check it out. I'll drop a link to this in the description for those who are getting started. But then I'm going to just give bite size of a bunch of stuff that you can do with Python, with NumPy using Python. Now, the next thing I'm going to do is that I'm going to create an array, right? First off, so we could create a simple NumPy array. So one really interesting thing is to create a simple NumPy array, you can use a Python list. Like Python lists are like cousins to the NumPy array, but they just offer two different things going forward. With a NumPy, with a Python list, you know, it's homogeneous data. You can have different data types, different data structures in a Python list. But with NumPy, you just store the values there as one type, right? So so that's why Python is heterogeneous and flexible like that. It's dynamic. But this flexibility comes at a cost, and so we're going to be looking at creating a NumPy array, right? So to do that, I will just simply, you can do this by simply saying np.array, that, and then you can just put a list of what you have. I just put some random numbers, and we have an array. You can see we have an array already. Right now, this is typically different from a NumPy list, a Python list, apologies. So a Python list will just typically be this alone. So let's just look at this. I take a copy here and I put it over here. So let me call this NumPy underscore numbers, right? And then I'll call this a list underscore numbers. So these are two different things. So you can see I use this over here and I store this here. Now there's a bunch of things you can do with an array, but you cannot do it with a Python list. There's a lot of things you can do with a Python list, like you can store different types of data types inside this. But of course you can do it here, but only one data type will be registered, and there will be an unsigned like data type for the other one. But again, one really cool thing is you can perform mathematical operations. You can have mathematical operations with NumPy, right? For instance, I'll give you a thing. So here we have a NumPy array. So this, if I print, which is NumPy underscore numbers, you can see it here. You can see how different this is. And if over here I print list underscore numbers, you see that there's a difference. You can see there's a comma separating both of them. Over here, I can say NumPy numbers multiplied by 2. And you can see what happens. Every element inside, there's a multiplication. So it's just like their individual features in here. Over here, I say list underscore numbers. So list underscore numbers multiplied by 2, and you can see what it does. Is like it feels like it duplicates it, right? Because here I can say divided by 22. So let's see what happens. Just look at that. Each element inside is divided by 22. Here, I say divided by 22, and I get an error right here. So you can see that there are lots of operations that can be performed using numerical Python. And so that's typically that. And there's a lot, right? For a lot of data analysis application, right? NumPy can do, data munging, data cleaning, subsetting, filtering. You can perform a lot of arrays algorithms like sorting and set operations. And you can do a lot of stuff with it, right? There's a lot of manipulation that can be handled by NumPy, and it stores data in a really cool fashion, and it is fast, right? Now in the next video, I'm going to just show you how fast it is. So just stick with this if you're getting started with NumPy, and we'll just keep walking through it one video at a time.